All right, it is Tuesday, and this is where we left off in the 4.2 notes. Okay, so now we're going to talk about sine and cosine as like functions, and eventually we'll graph sine and cosine functions. But if I were to write the sine of any angle, and your textbook uses like t as that variable, that's kind of what we were doing yesterday, where they gave you like, hey, here's some different angles, they use c. So if I were to write these as functions, like y equals the sine of some angle, and same with cosine, let's talk about what their possible like domain and range are, and then I'll kind of help explain what this period is, because they're periodic functions is what we call them. All right, so if you write these as functions, you can see here my input is the angle, right? That's what I'm like, my independent variable. That's what I'm choosing. That's what's different every time. The sine of this angle, the sine of cosine of negative pi over 2, whatever. So here my angles would be my set of my domain. So it's really all real numbers. I could write it in set notation. The domain is all real numbers, or you could do t such that t is a set of all real numbers. That's like that set notation. We don't use that a whole lot now that we do interval notation, but know that the domain is talking about the possible angles. There's infinitely many angles I can take the sine and cosine of, and it doesn't just restrict our options to the unit circle. Okay, I mentioned this before. I could do like pi over 9, okay, or I could do an angle that's negative. Any number we can really think of, whether we're measuring it in degrees or radians on a circle, we could represent that angle. So our domain's all real numbers. There's no restrictions for what I can take the sine and cosine of. Does that make sense? When we look at it in this context. Obviously, there's restrictions when we're looking at like a triangle, because you can't have negative angles on a triangle, but that's a worry for the next lesson. So basically, our domain is any possible angle. We can find the sine and cosine of it. So the outputs we get, the range, this is where the visual of the unit circle is. The range, and I guess I could just use this little circle here. Think of all the possible values I can get out for, let's just start with my sine. So my y values, or my y coordinates on the unit circle. So here I have a y coordinate of 0. So we're like, okay. And then they just get bigger and bigger and bigger. Think of you're measuring that vertical distance. Maybe that's an easier way to picture it. Until we get up here, we have a vertical distance of 1. And then those vertical distances get smaller and smaller and smaller, back to 0. And then in this direction, my vertical distance go all the way down to -1. So the possible like outputs I could get for my sine curve, if you look at your y-axis, what's like the smallest number we could get out? -1, right? And what's the highest value? 1. So the range of values we could get out for both of these functions, and the same for cosine. You could look at the x values. The range is just -1 to 1. Okay. So there's essentially your domain and range of sine and cosine functions, if we write them as functions, right? Y equals in front. Yes?
How come it's all real numbers for the domain?
Don't think about x for your domain. Think of t like our angles for the domains, because we're writing cosine as a function of t. Yeah, good question. Okay, so this helps us show that these functions are like cyclic, or like periodic is another way your textbook uses periodic, but it means it repeats cycle after cycle. Okay. So if you think about starting here at an angle, actually let me use the unit circle, at an angle of 0 radians, degrees, however you want to think of this. Let's do degrees because this might make more sense. 0 degrees. And then I go through all these possible degree measures until I make a full 360. And think about the sine values for a second. So they go from 0 all the way up to 1, all the way back down to 0, all the way down to -1, and then all the way back to 0. And then that cycle is just going to repeat, right? If I have anything greater than 360 degrees. So I do one full revolution, and I have all these y values, and then that cycle is just going to repeat. So that's why these are like periodic functions. And once we actually graph these, you'll be able to see like their curve is cyclic. It just has one cycle that just keeps repeating. And it ranges just from, doesn't go any higher than 1, any lower than -1. Just kind of looks something like that. And the same for cosine, meaning we're just looking at the x coordinates. Cosine, we start here at 1. Okay, we have all these cosine values getting closer to 0. Then they start going negative. They're down here at -1. And then they go back to 0, back to 1. And then that's just going to repeat and repeat and repeat as we go around our unit circle. So the period in radians for sine and cosine is 2 pi, because that's one full cycle and it just repeats after that. So you can just maybe put this in your notes. It's going to repeat after one cycle of 2 pi. That's what it means by periodic. The outputs of the function just repeat as the function grows. So as the angle gets like larger than 2 pi, or you can even do it in the other direction. If it's like smaller than negative, smaller than 0, like a negative angle, it's just going to keep repeating. We have 2 pi radians in one full cycle, and then it's just going to repeat. That's why it's periodic. Okay, so your textbook kind of like phrases it like this, like evaluate the sine and cosine using the period. And essentially you're just going to find like a coterminal angle and use your unit circle to answer this, okay? So remember when we found coterminal angles, we just added and subtracted multiples of 2 pi? That's basically we're adding like its period. It's one full cycle of where it's going to repeat. So it's essentially the same thing as like finding a coterminal angle, is you're just adding or subtracting like a full period to figure out where on the unit circle this is. Now, a lot of you, I mean, we did one yesterday where it was just negative pi over 3, wasn't it? And you guys were like, oh, that's just going to be 5 pi over 3. I was like, exactly. So a lot of you could figure out where negative 7 pi over 3 is. But now that we know it's just going to repeat after 2 pi, you can essentially just find its coterminal angle by adding 2 pi to this angle. So this is by using the period as its aid, but it's really just finding a coterminal angle. So remember, we need common denominators to do this. So it would be 6 pi over 3, and then we get negative pi over 3, and we see, negative pi over 3, that we can easily find on our unit circle instead of trying to count and figure out where negative 7 pi over 3 is. So then we can use that. You guys got your unit circles out or not? All right, sine of negative pi over 3. Negative root 3 over 2. Yeah. Negative root 3 over 2. Yep. So negative pi over 3. And now if you're like, well, that's not even on our unit circle, you could add 2 pi again if you really needed to, and you'd see, oh, that's 5 pi over 3. So that's right here. Sine, I'm looking at the y coordinate, negative root 3 over 2. Okay? That's all you had to do for that. Oh, maybe you should write your final answer though. So since these are coterminal, and guys, we could count easily in radians. I had you do this before we even knew what the unit circle was. You could figure out where negative 7 pi over 3 is. Cut your circle into thirds. 1/3, 2/3, 3/3, 4/3. Oops, not that one. Not that one. 4/3, 5/3, 6/3. And you just got to count negative 7 of them. So we got 1, 2, 3. And I'm going this direction because it's negative 4, 5. Negative 6 pi over 3 is one full revolution, one full 2 pi. Negative 7 pi would be at this same place. So you can use those same coordinates. Okay. So it feels a little redundant. You're like, didn't we kind of already do that? Yes, we did, but now just like connecting it to the value on the unit circle. So if the sine of negative pi over 3 is negative root 3 over 2, the sine of negative 7 pi over 3, its coterminal angle is also going to be negative root 3 over 2. That should be how you write your final answer. We call this, well, I call it, and I don't know what your textbook does yet. I'll have to look. I call this kind of like my reference angle. My reference angle is pi over 3 because it's coterminal with this angle, so I'm referencing that one to figure out negative 7 pi over 3. Okay, because this one I can find on my unit circle easily. Okay, kind of make sense? So 11 pi over 4, you're looking on your unit circle like, I don't see an 11 pi over 4 on here. You could count where it is. You could count in radians. Or just take off a multiple of 2 pi, take off a period, take off one cycle, however you want to phrase it. Take off one cycle, figure out where this is. 11 pi over 4 minus, that'd be 8 pi over 4, common denominators. Okay, that's the same as where 3 pi over 4 is. That's the same as 3 pi over 4. 3 pi over 4 and 11 pi over 4 would be coterminal. So now let's apply the unit circle. What's the cosine of 3 pi over 4?
Negative root 2 over 2.
Square root of 2 over 2. Yep, negative. We're in quadrant 2, right? Yep. Negative root 2 over 2. Just look at the x coordinate. Negative root 2 over 2. So to answer the question, the cosine of 11 pi over 4 is also going to be negative root 2 over 2. So I kind of used 3 pi over 4 to reference. Maybe I shouldn't call it. Reference angle is technically something else, but you're just using that to help you figure out where on the unit circle it is. Okay. What else do I need to tell you? Oh gosh, we're going to finish this pretty quick. And today's the day where I'll get to show you how to type these in your calculator for ones that you can't do on your calculator. You know what I did in high school on ones where we had our calculator, but I wasn't sure. Like, I'd use it to check my answers kind of with these unit circle ones. Can I show you my tricks?
Yes.
Now remember, you're gonna need to know like what the sine of pi over 4 is, tangent of negative pi over 3. So you're gonna need to know these without a calculator. But I just this is tough.
It's 11 pi over 6. What's the cosine?
I just kind of like memorized what the square root of 3 over 2 was as a decimal. So this can be a way you kind of like check your answer. And this is fine. I like just memorize it's like 0.866 really. So then in my calculator, like when I did the sine of 60 degrees, it doesn't give you, I might be in, shoot. I don't want to show you this yet. Never mind. I'll come back to this. There's a reason it's in, never mind.
Sure.
I will right here. I will get there. Don't worry. Okay. Save that thought. If that gets you excited, good. Before I show you the calculator tricks, one other thing we have to talk about with sine and cosine functions. And honestly, guys, a lot of this will like click more when you actually see the graph of it. Okay, do you guys remember when a function is even and odd? Do you remember what that means? Okay. No, not polynomial functions. I know what you're thinking of though. Even and odd, it has to do with symmetry. We did it in chapter 1.
Yeah, the maxes and like the dips, isn't it?
I think you're thinking of still polynomial functions that the turning point's a degree minus 1. I think that's what you're thinking of. Close. Y-axis for which one? And
Even is reflection over y-axis.
Yep, do you remember what odd is? This one,
No.
even means it's symmetric. And I feel like I maybe saw a problem like this on either the ACT prep where I saw like it had even and odd. So this one's symmetric with the y-axis. Oh, wait, today? No, not today, tomorrow.
Yeah,
today.
It's Miss Roach today.
Oh,
Miss Roach today, me tomorrow.
okay.
Odd,
Sucks to suck.
symmetric with, nope,
Origin.
Okay. So they're basically just telling you for now, until we graph these and you can visualize this, they're basically telling you for now that the cosine and secant functions are even. So how we test for even symmetry, or test for symmetric with the y-axis, is we plug in a negative, like you guys usually did negative x, and if it came out to be the same, it was an even function. Okay, remember that? Meaning it was symmetric with the y-axis. If it came out to be exactly the opposite, it was symmetric with the origin, meaning it was an odd function. Okay, so cosine and secant are even. So that means that the cosine of a negative angle is going to be the same as the cosine of that positive angle. Let's talk about why this makes sense on a unit circle in a minute. But its reciprocal holds that same property, that it's even. So it has y-axis symmetry. Okay. Obviously, I always like to conceptually understand things by looking at graphs, and we'll get there as I mentioned, but you can see this on the unit circle for now to understand this. So cosine are all my x values. So whether I have positive pi over 4 or negative pi over 4, I have the same cosine angle, right? They're both positive square root of 2 over 2 because cosine, which is x, is positive in both these quadrants. Okay, so that's basically what this statement says. The cosine of a negative version of an angle, like negative pi over 4, is the same as the cosine of the positive version of that angle. And that'd work for any angle. That's why it's considered even. And you'll be able to see the symmetry once we graph it. Its reciprocal would hold the same properties because you just flip-flop the numbers. The other 4 guys, sine, cosecant, reciprocal, tangent, cotangent, those are odd. Meaning that when you take the negative version of an angle, you get the opposite value of the original angle. Okay, so that works for sine, its reciprocal cosecant, tangent, and its reciprocal cotangent. Okay, we'll look at a unit circle to show you this. Sometimes folks too, I'm kind of picky on, if the angle's negative like this, kind of like I was with logs. If you have a negative expression, we call that the argument. You need to put it in parentheses. But if you have just a plain old variable like this, you won't commonly see textbooks wrap parentheses around it. They'll often just do the cosine of x with no parentheses. But once you have a bunch of stuff in it, make sure you're kind of wrapping your argument in parentheses. I believe I did that when we did the actual angles. See how I wrapped them? This is what we're taking the cosine of. I'm kind of picky about that. Okay, so here let's take the sine of, we'll do pi over 4 again. So the sine of pi over 4 is what? Square root of 2 over 2. So the sine of negative pi over 4 is exactly the opposite. Okay, so that is that odd, symmetric with the origin, that odd property. Same with tangent. Okay, and the reason why is because sine is y, so you can see the positive here, negative here, and tangent is y over x, so same with tangent. If I have positive 1, the negative version of the angle is exactly the opposite. Okay, so know those. Here's an example problem with each of these. It says use the given value to evaluate each function. So you're telling me the sine of some angle is 1/2. You don't have to find the angle. I mean, I know you could have your unit circle. Find the angle that has a y coordinate 1/2. You don't even have to do that. But what would the sine of this opposite angle be? Well, you look at those properties we just listed. I know the sine of the opposite angle is going to be opposite of that coordinate, so it's just going to be negative 1/2. Okay, so I kind of essentially just use this property. It's going to be the opposite of the sine of that angle, which they told me that was 1/2. What would the cosecant? It is odd, So it's going to be negative. And its sign's reciprocal. Good. So it's going to be negative 2 over 1. You got to do the reciprocal. It's going to be negative 2. Nice.
Why?
Because these are reciprocals of each other. So you have to flip the coordinate like this too. Sine is whatever y is. So cosecant is its reciprocal. It's 1 over whatever y is. They're reciprocal identities of each other. And it goes back to the reason like y is, it defines that other ratio of a right triangle, the reciprocal signs. All right, so cosine is even. So the cosine of some negative angle or some opposite angle is negative 1/5. So the cosine of that positive angle is going to also be what? Negative 1/5. Okay, they're the same. Values are the same. For even. So the secant, this one's a little different. The secant of negative t, whatever that angle is, this one we wouldn't know on our unit circle. There's no x coordinates that have negative 1/5. But I know the secant is just going to be the reciprocal of this, so negative 5. Okay, there's something like that in your homework.
Can you go back to your odds functions?
The identities. Cosecant and secant are the only even ones. Everything else is odd. Okay, now it's time to show you the calculator tricks.
Disgusting.
Yeah, it does it automatically.
Whatever.
Syntax errors.
You guys know how you guys tally how many times I do something wrong? I want to start telling every time you guys whine. Who do you think would win?
Are you about 4 now, or are you just holding that?
Slavic might win.
Why does it with a purpose?
Can we get a habit every time?
Mine was the purpose. I don't know
Yeah,
how to
every
work
time
this
we
thing.
think it's a syntax
that.
error.
No.
Okay,
I'll just put right here.
Great, this is working.
Homes or homes.
You're smart. You're so smart.
Then I'll purposely not do it.
or we could tell you the amount of times I say how much I hate my board.
We should.
Every day, 18 times a day. All right, I might have to actually type this out.
I'll
We're just gonna trade
purposely not do
calculators.
it.
Okay.
That can't help yourself sometimes, man.
I should buy that.
Just like frozen. Let me try to read one.
One
Sigh.
140.
I heard it.
9.
Give her the benefit of the doubt on that
Isn't that wrong?
It's just frozen.
Like the movie.
I think. 104. Maybe 104.
What doing?
I said, was I close?
Oh my gosh, do I have to do the old-fashioned way or the dot cam?
What's 1?
Disgusting.
Oh, 104.
I have
104.
video going. I see I'm not sure.
Frustrating.
I was
I feel like I wanted to.
Yeah.
Oh, yes. It won't even let me like close out of this.
I said
Sure.
But it was really
I wrote the table down.
All right, I'll just use my dot cam and show you on this one.
I used to. Well, the averages. Those. Well, they also have 2 classes.
Oh, it's probably.
What doing?
Okay.
Getting an
My
A5.
always look at people like that.
It's loading. It's turning on. You can actually do this with these ones too, I think.
Negative too.
The cosine. All you gotta do is just press
You should look
cosine
at
and
Kane's
then
calculator
put the
and then make him not use it on the test and quiz.
Oh yeah, I know how to do it on this one. Okay, yeah, sure.
If
Go
this
ahead.
was glass,
Try for it.
Reorganization, you're
Distracting.
You would be.
Okay, everybody take out your calculator.
My calculator stuff.
Oh, you're using that?
Well, this one's not
Your
real.
batteries.
My battery life
Okay, so the reason why my calculator gave you a weird answer when I tried to do the sine of 60 is because it's right now it's in degree mode, and you can change it to radian mode. so that you can take the sine of pi over 3. And that's what mode mine was in. So you're going to hit mode. Everybody see where mode is?
Yeah. Radian.
No.
Right here.
Mine's in radian.
Mine's already in radian.
Same.
Okay, good. It should be in radian.
That's good.
It's probably left over from last year. Yeah. Anytime you're doing right triangle stuff, eventually you might have to switch back and forth. So it is good to know how to move from mode to mode. So if you go down here, you want it on radian mode. If yours is in degree mode like this, you just hit over the arrow and you hit enter. Put it in radian mode. We want to be in radian mode. So now I can do the sine of pi over 4, and it'll give me that, which is square root of 2 over 2. And this is my trick in high school. I just memorized what these were, these numbers, because your calculator's not going to give you exact. I did sine of pi over 4. You can do whatever you want. You can do the sine of pi. Sine of pi we know is 0. Sine of negative 3 pi over 2. We could do that.
0.70.
Oh my god.
Oops, I did the minus instead of the negative.
One.
Negative. I get 1. Negative 3 pi over 2. That is hard to see.
No syntax errors today.
Can't wait to get some
Turn the
brightness
down.
You want me to try color the window, guys?
On this screen.
Yeah.
Oh. Is that better?
Yeah.
Sine of 2 pi 0. Okay, so now we're in radian mode.
Wait, how come the sine of pi equals 0, but the sine of 2 pi equals 0?
Those are these 2 points on your circle.
Why does
Pi,
Yeah.
2 pi.
Oh, it's giving the y value.
Y. Yep, sine always gives you the y value. Yeah, so you can do cosine too. Cosine. Cosine of 2 pi would be 1. Yep. Cosine. So here is this is kind of my trick. So you'll never write the answer. If I ask you what the sine of pi over 4 is, now I'm not going to give you a calculator, but in the future, when you just have to know what the sine of pi over 4 is, let's say you forget, you're like, oh, is that square root of 3 over 2? 1/2? Which one was it? I just memorized, I would do this. And I was like, oh yeah, that's square root of 2 over 2. I just memorized what those were as decimals. You could do this too. What is the square root of 2 over 2? You get that number. So that can help you too. And you're like, and you do cosine of pi over 6. This one's square root of 3 over 2. And you're like, I forgot which one that is. Square root of 3 over 2. Oh yeah, that's that one. Square root of 3 over 2. That was how it helped me. That was my trick I was going to show you. Okay, let's do the ones from the note packet. So it says, now, anytime you have an angle that's not on the unit circle, not a multiple of pi over 3, pi over 4, pi over 6, or one of those quadrantal ones, 0, pi over 2, all that good stuff. Something like this. Negative 3 pi over 11, not on a unit circle. It's something like that you have to use your calculator for. Okay? This is technically in radians, negative 4.2. I know there's no pi, but that's technically anytime you don't see a degree symbol, we're measuring in radians. Okay? And that goes back to what we talked about in 4.1, where a radian is really the arc, when the arc length equals the radius. So negative 4.2 radians would be just a little bit past negative 3.14 radians, which is pi. Okay. Anyways, cosine, negative 4.2. We're going to round to 4 decimal places. Make sure the calculator is in the correct mode. So cosine, negative 4.2, should get that number.
Yes, I got it. Of course, always.
What does that number mean?
Is it the X value or something?
Yep, exactly. So let's talk about that. All right, so as I was just talking about, oh shoot, then I took out my unit circle. So
Wouldn't that be 4903? No, you don't. When you do that.
Okay, Connor asked a good question. So negative 4.2 radians. This would be negative 3.14 radians. So you just know it's like somewhere over here. And cosine is negative in that quadrant, so it makes sense that we get a negative answer. So it's negative 0.4. So let's see, this is it's obviously going to be somewhere around here because this is like negative half.
If that's 3.14.
Oh, it actually be here. Negative half would be a little bit, or negative 0.4 would be a little bit before negative half.
Wait, you said it's 3.14 radians or 0.3?
This pi would be negative because I'm going this way.
Yeah.
3.14.
So, but this is negative. Oh, we're looking at the negative 4.2.
Yes, that's radians. So it's going to be just past negative 3.14, somewhere up here. And I figured out it's going to be about here because we got the x coordinate, the cosine, to be negative 0.49, which is really close to negative half. So it's going to be like just to the right of that. Does that make sense?
Yeah.
So that angle, negative 4.2 radians, is going to be somewhere right there. I wish there was a way I could like clear the ink from here. There's got to be.
Delete the whole thing.
No, that's not.
What about the pen?
What about undo?
Was there an eraser?
Rotate.
It looks like the shell.
That's a highlight.
Anywho, doesn't matter. Okay, let's try the next one. Tangent of pi over 8. So pi over 8, let's think about where that is. Pi over 8 is like somewhere down here. So before I even do anything, should I get a positive or a negative value out? Positive. Everything's positive in quadrant 1. Everything. X coordinate, y over x, everything's positive. So tangent of pi over 8. Oh, I forgot this one don't work. Tangent pi over 8. I just use the division symbol. Pi over 8, we get 0.414. Another reason why that makes sense, think of square root of 3 over 3 as a decimal. Is like 0.5, so obviously that pi over 8 is going to be less than pi over 6, so that tangent value is smaller, that y over x is smaller. Okay, the reciprocal ones. There's no button in your calculator for cosecant or for cotangent, so you just have to type in it as its reciprocal's identity. So you're going to do, for cosecant, you're going to type that in as 1 divided by the sine of that angle, and it'll flip it for you. It'll do the reciprocal. You don't do the reciprocal of the angle. You just take the reciprocal like of that value, or 1 divided by that.
Would you do the reciprocal? Just the...
No, sine to the negative first, that's inverse. That's something different. That's inverse sine. We'll get there.
Could
What'd you
just
say?
do sin and then flip them?
Sign.
Sine.
Well, you're gonna get a decimal.
Sin and
You're gonna get a decimal.
Yes.
So, I mean, you could do this. The sine of negative
I used to say sine until I knew sin.
Sin
3
like
pi.
syntax error.
What's that?
I also, folks, like this. If you have something like negative 3 pi, I like wrap that in parentheses too. Just like, hey, this is my numerator. It's negative 3 pi divided by 11. Now,
Negative 1.32.
I would do 1 divided by this,
Man, that insert button really saves lives.
right?
It's still, yeah, the divide by 0.
Um,
Do it wrong.
If you wanted to, Ashton, what you say, like do the sine of negative 3 pi over 11, and then you can just do 1 divided by that number. 1 divided by second answer. You'll get the same thing. You can't just obviously like flip it because it's not a fraction.
I guess.
All right, so this one we got
Negative 1.
So maybe just write this in your notes for the reciprocal ones. For cosecant of any angle, you gotta do 1 over the sine of that angle. It's reciprocal identity. For secant, what's secant's reciprocal? Cosine. What about cotangent? Tangent, yep. So for this one, we'd have to do 1 over the tangent of negative 11.5.
Oops.
Last year I had one of my algebra students take a whole test in degree mode instead of radian mode.
Oh,
Not good.
Got a couple scratches.
All right, let's try this one quick. 1 over 1 over tangent of negative 11.5. Should get that. Okay.
wow.
That's a wrap. Those are 2 long lessons. It's not
Wait
right.
till
It's
we have
just
to
new.
graph them.
No, the hard part is memorizing this stupid circle.
What is 9 plus 9?
Yeah.
Why? Are you asking me this?
What's 9 plus 9?
Come on, I want.
19.
Is that right?
19.
Yes, sir.
She's so
Hold on, let me stop
cultured.
it.
No, that's a serious question.
Serious question that I knew you'd answer.